All right, here we are. We got solving maximum and minimum values by modeling problems with a polynomial function. So, really what we're going to be doing is now we're taking the learning we've had and applying these to some kind of real world problems, to some word problems, and figuring out um, how would we uh, how would we answer these questions. And so, step one is that we've got to figure out what is the polynomial function. So write the polynomial function given in the information of the problem. So here's our example problem, and it says two numbers have a difference of 6. So we've got difference, and what are our two numbers? Let's call them just x and y out of convention. So difference is subtraction, so x minus y, and it says that they have a difference of 6. So x minus y equals 6 here. Their product, we're looking for their minimum product. So x times y, we want to be the minimum product. And that makes sense because if you thought of any two numbers that are 6 apart, maybe like um, 10 and 16, that product is going to be much smaller than, say, 100 and 106. That's going to be much bigger. So hopefully we can see that the maximum product just wouldn't make much sense because you can always get bigger and bigger numbers, multiply them together. So we're looking for the minimum possible product. Now we've got some of our pieces put together here, and so we are going to um, plug them in. So I guess really we should first determine the domain of the function. Um, for this one, we're just dealing with two numbers, so there's not really any um, domain that limitations. We can plug in any numbers we want. Just they need to be six numbers, six digits apart from one another. All right, so let's start working through this. Um, how can we, and it does say step 3, use a graphing calculator to locate a maximum minimum. This one we want to actually avoid whenever possible. In this problem here, we can solve without a calculator. Though later on we will learn how to use your calculator to find those local maximums and minimums. But first, let's figure out how to do it just kind of with our reasoning and with our math skills. So we've got x minus y equals 6, and um, I've got this other part over here. This is x times y equals the minimum product. But with these two variables, that's going to be too difficult to solve. So I'm going to take our difference over here, and let's solve for y. So I'll subtract x from each side. That leaves us with negative y equals 6 minus x, or write that a little more standard convention. So negative x plus 6, and then divide everything by negative 1 to get that y is equal to x minus 6. And now we've got y here, and we can substitute that in for y over here. All right, so we'll have x times x minus 6 is again going to be our minimum product. We want the minimum of our function. So here's our function m of x. We're looking for the minimum, and we've got x squared minus, x squared minus 6x is that function, and just call it m of x. And we're looking for the minimum here of this function. So hopefully you're seeing, hey, this one here is a parabola. I know how to find the minimum and maximum of a parabola, because remember, we learned up earlier on that the maximum and minimum of a parabola is at the vertex. I know how to find the vertex. So we've got a couple different ways. One would be if it's in its factored form, right here. Let's go with that one first and just kind of sketch out what's occurring here. I would have a factor of 0 and a factor of 6. So at 0 and 6, I'm just kind of sketching it out. Now if I've got 2 points, remember another thing about parabolas is that there's that axis of symmetry. And this point is at 0, 0. And it's getting reflected over here to 6, 0. So I could reason through and say, hey, that the axis of symmetry has to be at x equals 3. Now to find out where the actual vertex is, I would plug it back in. So 3 times, I'm using again the factored form right now, 3 times 3 minus 6 equals where my vertex would be, so equals y equals m of x. And we'll have 3 times, 3 times negative 3, which gives us y equals 9, or equals y equals negative 9. And so we just found our vertex through the factored form. So at 3 was our input, and our y value was negative 9. So our input and our output, meaning that our x value would have to be 3, meaning our y, which is going to be 6 left, would have to be negative 3. There's our possible x and y values. And actually I probably should go back and be more explicit not to use y here. This is the function, and we call it m of x. M of x, m of x. Butchered that one. M of x. Okay, because our domain here, our x-axis, is the x value, the value of the first number. Our output, our y, our range, isn't y. Our output is the product of mx, so of x times y. And just to be really explicit with it, our graph would look something like this, and our minimum is at 3, negative 9. So here's the two numbers that would give me that that minimum possible product. It says find what that minimum possible product is, and it would be negative 9. Let's say we had want to do the same thing though with that was in factored form. Let's leave it in standard form. So x squared minus 6x equals m of x. And if it's in standard form, we've learned that the axis of symmetry, or the x value of the vertex, is at negative b over 2 times a. And our a value is 1, and our b value is negative 6. And if we plug these in, we'd find out that, again, we get that x value of 3. So we have negative 6 over 2 times 1, which gives us negative 3. Okay, we found that same, positive 3. So we found that same x value, that 3 would have to be our x, and if we plugged in 3 minus what gives us 3 minus y, and so we kind of assumed that there earlier, but if it was 3 minus y equals 6, we would subtract 3 from each side and get negative y equals 3, meaning y would be negative 3. And now just again, our minimum product, we want it, so x times y gives us negative 9. All right, hope that helped, and we'll get some more practice on these word problems as we continue.